Okay, this is the second of videos for February 13th. And this one talks about the what would have been the in-class activity. Now, I'd really like it if you go online to Blackboard before you watch this video and have a look at this activity and try it. Try it out. I'll post the worksheet up online. You can do it. Um, Once you've done it and had a go at it, you can listen to my explanation now. But really, first try it out yourself. So this is my take on this activity. And the first part is just an explanation of what we've talked about before, just written out for you. Of course, you should also see this in your book, and you can, of course, watch the first video. And this is even something we talked about before. Now, what did we sort of try to hammer home? We tried to hammer home the fact that with arithmetic sequences, the sequence of differences are constant. For quadratic sequences, the sequence of differences are constant, which is to say the sequence of differences is an arithmetic sequence. So what we'd like to do is know, when are we dealing with a quadratic sequence? So the first question here asks, which of these sequences are quadratic? And how do you know? Well, how you'll know is you'll be able to find that the differences, or the sequence of differences, ended up being constant. So let's try it. Let's take the first one. Let's take 4, 6, 9, 18, etc. So what about this one? So what do we got? Well, I like writing these out in tables, as you well know by now. And we're going to introduce some notation now for you. Give me a little more room there. Some notation is sometimes people like to write for difference, rather than writing capital D, they like to write a delta for the difference. So this is our sequence, S sub n, and this is our delta. And then this, they sometimes write delta squared, a delta to the second power to indicate the second difference. Okay, so let's take a look at that. All right, so let's take a look at our differences. The sequence starts out at 4. What's 6 minus 4? Oh, that's 2. What's 9 minus 6? Oh, that's 3. What's 13 minus 9? That's 4. What's 18 minus 13? 5. And what's 24 minus 18? 6. Okay, that looks kind of like it's increasing by 1 each time. Why? Because 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. Yup. These are constant. These are constant. So the sequence is quadratic. All right, let's try this one. 2, 4, 8, 16, 32, 64. So let's take a look at it. Let's look at our Sn, look at our delta, and look at our delta squared. Okay, 2, 4, 8, 16, 32, 64. Okay, so what's the difference between 4 and 2? Oh, that's 2. What's the difference between 4 and 8? That's 4. What's the difference between 16 and 8? It's 8, 32, and 16. Whoa! Whoa, 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 whoa. That's the same sequence. Same sequence. Well, let's try taking these second differences again and see if we get something different. Well, of course, we're not going to, right? 4 minus 2 is 2. 8 minus 4 is 4. 8, 16, 32. This is not constant. So not quadratic. Okay. Well, what about this one? What about this guy? What is the next one? 12, 16, 17, 15, etc. Let's make some room for this guy. Okay, here we go. 12, 16, 17, 15, 10, 2. Okay, so what's 12 minus 16, or what, rather, what's 16 minus 12? The sequence is, yeah, the sequence is going up. What's 12 minus 16? That's 8. What's 7 minus 6? Or 17 minus 6, that's 1. What's 15 minus 7? That's a negative 2. Right, 15 is smaller than 17, so it's going down. What about 10 minus 15? That's negative 5. What's 2 minus 10? That's negative 8. All right, so let's take a look at these differences. What's 1 minus 8? That's negative 7. What's negative 2 minus 1? That's negative 3. And at this point, you can say, uh-oh, not, they're different, not constant. So not quadratic. Okay. What about the next one? Negative 3, negative 6, negative 8, negative 9, negative 9, negative 8. Getting a little cramped there on the bottom of the page here. Let's move it. Okay. So let's see here. What's negative 3 minus, or negative 6 minus negative 3? Negative 6 plus 3, that's negative 3. Negative 2, negative 1, 0. Now it's going back up. 1. All right, what are these differences? These differences are, let's see, negative 2 minus negative 3 is 1. Negative 1 minus negative 2, that's 1. 0 minus negative 1, that's 1. 1. These are constants. So this is constant. So it's quadratic. All right, and the last one. 3, 5, 8, 12, 16, 21. So what's 5 minus 3? That's 2. What's 8 minus 5? That's 3. It's 12 minus 8. 4. 16 minus 12. 4. What's 21 minus 6? That looks like 21 minus 6, I think, is 5. Okay. Kind of looks promising. Let's see. What's 3 minus 2? 1. What's 4 minus 3? 1. What's 4 minus 4? 0. Uh-oh. Nope. This one looks really close to being quadratic, but it's not. Not quadratic. So that's how you can tell. So you can tell if sequences are quadratic or not. So let's see. That sequence of differences is what kind of sequence? Well, it's an arithmetic sequence. Delta S is an arithmetic sequence. We're using that delta in there to represent the name of the sequence. It's an arithmetic sequence. It's an arithmetic sequence. Goodness, I should be correcting my grammar here. And on a tablet such as this, it's not a problem. What happened? Oh boy. Oh, it is an arithmetic sequence. Okay, so what kind of sequence? Find a difference equation for it. Well, here are these 1, 3, 5, 7. What is it? Well, let's see. That's an arithmetic sequence. What's the difference between these two terms? 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is also 2, right? Each of these differences are 2. So let's see. We have an arithmetic sequence that starts at 1, has a difference of 2. So you could write it as an is, well, 1 plus n times 2. That'll work. That's the functional equation. Or you could say a sub n plus 1 is a sub n plus 2, where a sub 0 is 1. That also works. Okay, now it says do the same procedure for all the other functional equations that we found that were quadratic. So that's for each of these. I think you can do most of these guys. Here, let's take the first one. The first one is the 4, 6, 9, 13 sequence. That's this guy. And what did we see? Well, we saw, here, the great thing about a tablet is we can just pick this up with us, copy, and paste. Here it is. And we've got some additional dregs here. Hold on. Okay. Right, so there's the sequence. And let's see, we know that the differences there they are. We're going to try to write this arithmetic sequence. Say D0, or perhaps we can say delta S0 if you like. And what is that? That is 2. And delta S n plus 1 equals delta S n. And what's the difference? The difference is 1. It goes up by 1 each time. You could also write this as a functional equation. Delta S n is 2 plus n. That'll also do it as well. Okay, so for the next video, we'll finish up this activity. There's one more page to it, and I'll see you then.